little bit related to the first presentation.
Yeah, prefer so. Yeah.
Technical team, presentation number 3, please.
Okay, can you hear me? Yeah. No? Okay, so my name is Frode Drevland. I'm from the Norwegian University of Science and Technology in Trondheim. And I'm going to present this paper that I've written with Vicente Gonzalez at the University of Auckland. Let's see. The hospital is a machine, the design of which facilitates or impedes its fitness for use. This quote by Dave Chamber, Chief Architect of Sutter Health, I've cut and pasted from Glenn Ballard's 2008 paper and updated to the Lean Production Delivery System. So the idea that buildings are production assets basically has been with us at least 10 years. But I would argue that, really understanding them as such has not. So how do we evaluate buildings? Perhaps I should not use 2 mics. How do we evaluate a building's fitness for purpose at design time? So methods like post-occupancy evaluation and evidence-based design, right? Loop back information from actual buildings into the design process. But if we have an actual building design, can we evaluate how well it will work for a purpose? So of course there are research looking into using computer simulation to simulate the use of a building. The problem that we found with this research is that it tends to put the proverbial cart before the horse. It looks at, yeah, we can simulate people walking through the building and doing this and that, and the question is why? So a key tenet of computer simulation is do not model to more detail than what you need to get to answer what you need to get answered. And this is sort of like what's lacking, There's no, what are the answers we need during the process to improve the design of buildings so that it will better suit their purpose. So what are the questions we want answered? And this is a model I'm fond of from business process engineering. It explains the role of buildings in the whole. I don't know if you can read this, but this is basically, process, how work gets done. There's infrastructure here, buildings. It's to support how work gets done. So buildings are infrastructure for production systems, and determining building performance entails evaluating the performance of the production system and how work gets done in them. And this, we argue, should be founded in a production theoretical understanding of buildings and the production systems that they house. So just to give a brief overview of a couple of fundamental production theoretical concepts. So there are 2 fundamental types of activities that take place in production systems. There are transformation activities, value-adding processing of product or service, and flow. That's all non-add value-adding activities, waiting, moving, inspection. And all production system contains variability, and variability must be buffered. If variability is not buffered, ad hoc buffers will appear. So let me give you a very simple example related to buildings. Take bathrooms, right? You can buffer with capacity, having extra stalls and urinals, or you can buffer with inventory, people standing in line waiting to use the bathroom. Now you can plan and have a space for this, or if you don't have a space for it, people will just queue up wherever. An ad hoc buffer will form, and this could impede transport, etc., through the building. So buildings house production systems, and to determine if a building design can support a specific production system, we will argue that we need a model of the production system. And we refer to this model conceptually as a building activity model, or BAM for short. And such a model must contain information about all the activities of the production system and the relationship between them. So then, to determine if a building is fit for purpose, given that we have a BAM, we propose you can do what's called a BAM evaluation then. And at the activity level, there are two fundamental questions we want answered. Can the activities be done? How well can they be done? And there are probably also aggregate indicators we would like answered, but these would depend on the type of system we're talking about. So I'll go a bit into detail on this. But first, let's just cover, in principle, what are evaluation methods. So I mentioned simulation. That's techniques for using computers to imitate the operation of various kinds of real-world facility processes. However, there is also possible to use so-called analytical techniques, to which you can subdivide this between verification, showing that all system directories satisfy the desired property. This would be a yes or no answer. Can we do something? Or calculation, doing mathematical operations on system variables, which will yield a number. In either case, the models that we use can be either deterministic or stochastic. A deterministic model will have all the input variables known, no the probability distribution or anything, while in a stochastic model, one or more of the input variables will be uncertain. So to answer the question, can the activities be done? A verification can suffice is to determine if an activity can be done at all. Like, can we have a meeting with 10 people in this building? Okay, is there any meeting rooms that's big enough? Of course, but if we're going to determine capacity, how many meetings can we have? Some calculation might be done when you get to a certain complexity, right, we will have to simulate it because there are so many uncertain input variables. How many meetings a day, etc. Or scenarios where we have high variability. An airplane arrives at an airport and dislodges a lot of passengers who needs to use the bathroom. And then there's the question of how well the activities can be done. Now, activities can underperform for one of two reasons, based on our production theoretical understanding. There are the flow issues, those that cause an activity to be starved of material input. For example, staff spending a disproportionate amount of time waiting in line or hunting for bathrooms if the capacity is too low. Process issue. This would not cause non-performance, but they will cause degraded performance. This can be related to the characteristics of the building. So, for example, suboptimal lighting or noise in office landscape will reduce productivity. While some aspects of this determinism can be determined by simple calculation, this is, the interdependencies in a production system between activities will typically be so great that you really need simulation. At the aggregate level, so again, relevant measurement parameters will depend on the system. We would argue that, production systems can be seen as either resource or flow-oriented. In a flow-oriented system, typically has physical products moving through them. And here, the parameters probably would be of interest are those that would make up Little's law, like throughput, work in process, cycle time. Well, the resource-oriented system, would be typically be knowledge work center, like office buildings. You don't have a physical product that's flowing. So here, the parameters would probably be resource utilization, the causes for non-utilization, and activity quality, right? So if you're getting interrupted by noise, etc. So, to sum up, evaluating the benefits of a building at design time requires an analysis of its ability to support the production system that it will house. To do so, there are two fundamental questions that we must be able to answer. Can the activities of the production system be performed? How well can they be performed? And to fully determine to which extent the proposed design will support the activities that will take place in it, computer simulation is required. So this is, how am I on time, by the way? Oh, lots of time. So then I'll just go off script. So this is a sort of preliminary research. The idea was start looking at simulation, but we decided we needed this part first. We need this understanding of buildings and how can we then describe an activity model. And I hope this made some sense. I sort of fear it didn't, because it's the paper, I guess, is a bit has sort of a dense argumentation, and condensing it down was challenging. But okay, I'll let you answer questions afterwards. So I'll leave the next speaker.
Okay, thank you.